Okay, so we are about to enter the second portion of this unit. We have done the graphing portion. Next part is the algebraic portion. And then thirdly, the chapter 4 material is part 3. It's basically once we learn how to divide polynomials, guys, once we learn how to divide polynomials and factor higher degree polynomials, that's basically the goal for this week. Other than you writing the quiz on Thursday, our goal is to get through this little mini package you got today to finish chapter 3. Once we do that, chapter 4 is still polynomials, still polynomial functions, but it's solving polynomial equations and inequalities. So basically all that happens is instead of it being a graphing exercise, a factoring exercise, or a graphing exercise, it's a solving exercise. So how do I solve for my variable? Okay? So let's start with the first thing, which is we need to learn how to divide polynomials. It's going to be a key step in factoring polynomials of degree 3 or higher. So before I teach you how you're going to do this, we're going to remember how to divide using long division. So, long division. Do you guys remember there was like a setup you would do on your page? This doesn't look familiar? You want to divide 123 into 2017. How many times does 123 go into 2017? So, the strategy was, if you remember, is try to deal with a smaller problem first. Instead of dealing with 123 into 2017, how about I cover up the 7 and say how many times does 123 go into 201? Once. So we put a 1 on the top.
And then you can put a 123 under.
Because you multiply, right? 1 times 123 is 123. Okay?
Girl, like, this is what I've been waiting for. This is so like,
okay. Your math learning stopped at grade 6? Okay. So, I think so.
You bring the 7.
Divide? Okay.
Oh my.
Okay, guys, stop complaining. Okay. So now I need to subtract. So again, I don't want you to necessarily just jump to your calculator. How would you have done this in grade 6?
Wait, miss, is it 2017 divided by 123 or 201?
It's 201 minus 123. The 7 I'm not dealing with yet.
a little arrow.
Okay, guys. It doesn't need to be a commentary right now. Okay. Question, yeah.
So you can't like subtract 3 or
Right.
1. So but you can't take anything from the 0. So you take from the 2 and you cross that 2 out and put a 1. You make that 2 into a 1 and then you make that 10, that 0 10. But now it's going to be a 9 and that's going to be an 11.
Or you could just cancel 20 and make it 19.
What?
And this becomes 11.
Yes.
Borrowing. Remember borrowing? You borrow from the digit to the left, No? Okay. So 11 minus 3 is?
8.
8. Okay. 9 minus 2. Sorry. 9 minus 2 is 7. Okay.
78.
So 78. But I'm not done. I have to bring down the 7. And then how many times does 123 go into 787?
5.
So you could try 5, but I think it might be a little low. I think 6 is 6 will work. And you'll know, guys, you would know you would know you made a mistake is if you did 5 and you got a number bigger than 123, you know you could have put an extra digit in, right? Or you could have added 1 to your number.
If you got there, then
123 times 6.
Well, no, it means you didn't divide by the biggest thing you have to fix it. Yeah. So it'd be 6.
738.
6. So again, how am I getting this new number? I'm doing this thing. Remember how this works? 6 times 3 is 18. Carry the 1. 6 times 2 is 12 plus 1 is carry the 1. 6 times 1 is plus 1 is.
Wait, when does it get to the one we have to add like a 0?
That's decimals, isn't it?
No, isn't that when you do 2 digits? Oh, yeah.
Okay,
Oh my God.
so now, so 17 minus 8 is 9, 7 minus 3 is, okay, now, let's see if you remember terminology here. The number you divided into that has a name, it starts with a D. Dividend is here. The thing you divide by, divisor. The result of dividing is the quotient. And the number that's left over at the end.
Remainder.
Yeah. So I was telling people in period 1, when you go home tonight and you're having your turkey leftovers, you can actually say, no, we're having turkey remainders.
What do you mean when you go home tonight? Is that for lunch too?
Yes. You don't have to worry about it for the purpose.
Wait, so then what's the answer? 16 or 49?
So the answer is 16,
But then,
with remainder 49. So it doesn't go in evenly.
oh, is that when you have to write like the R and then?
Yeah, this is the R. Okay, but here's the deal. So I now painfully brought you through long division with numbers. Okay, we need to now learn how to do long division with polynomials. I think you're going to find it honestly easier because you've been working more with algebra lately than with doing this lately. Okay? Is this really what we need to be doing right now, guys? Guys, it's math class, grade 12. Really, is phones really the important thing right now? Okay. Polynomials can be divided in much the same way that numbers are divided. Okay? So what that means is we can still set up the exact same process. Okay? So we're going to have our lovely dividing. Guess what's going to go inside? What are you dividing into? This, whatever the first thing is, that's your dividend. Divide that by this. This is the divisor. So 3x cubed minus 5x squared minus 7x minus 1. That's what I'm dividing into. I want to divide by x minus 3. That goes out there. I hope you all remembered you need to leave a space because remember your answer is going on top of this. Now, here's what I did period 1 and I want you guys to do the same thing. I'm going to do this twice. I want you the first time just watch. So put down your pencil, okay, and just watch the process, okay? Okay, you have to ask yourself this question as you're proceeding through this. Your focus is going to be on the first term here in your divisor and the first term here that you're working with, and that will change as you go through the process. But at the beginning, the first thing I'm looking at is 3x cubed. You're basically going to repeatedly ask yourself this question. What do I multiply this by to get 3x cubed? X times what is 3x cubed? 3x squared. So guess what I'm going to do? I'm going to look at my squared. You see how it's all organized? Cubed, squared, linear, constant? So I'm over the squared, I'm going to put 3x squared. And now I'm going to, just like you would do with numbers, I'm going to multiply 3x squared times x, 3x cubed. But I have another part to my divisor. I've got to multiply it as well. 3x squared times negative 3, negative 9x squared. I'm now going to subtract, but instead of subtracting numbers, I'm subtracting polynomials. But do you get that the first term is, you purposely have done this, it's gone, right? Because 3x, you purposely chose this so that you would cancel that out, so it's gone. But the second part, I have negative 5x squared minus negative 9x squared. So you have to be very careful with your integers. Negative 5 minus negative 9, 4x squared. And then, just like we brought down the 7 in 2017, I got to bring down the next digit. In this case, the next digit is the next term, minus 7x. Now I'm going to ask myself that question again. What do I multiply x by to get 4x squared? 4x. I'm going to put a plus 4x. because we want it to still be a polynomial. We don't want just like terms. We want to kind of keep it as a polynomial. So positive 4x times x is positive 4x squared. Positive 4x times negative 3, negative 12. Here, 4 times for multiplying. 4 times 3, 12x. Okay? Okay, so same deal. 4x squareds are gone. Negative 7x minus negative 12x is 5x. Bring down the next digit, the next term. Last step. What do I multiply x by to get 5x? 5. 5 times x is 5x. 5 times negative 3. And I subtract. And I get negative 1 minus negative 15 is 14. Okay? So, your quotient is 3x squared plus 4x plus 5. Remainder 14. You have successfully divided the two polynomials. Okay? Now, if the question is, I'm gonna go through that whole process and you can copy with me, okay? I'm gonna do it again. But what we do is we state if it just says divide, then basically your work here, and maybe you could just kind of summarize what the quotient is and what the remainder is. So I know that you know what you found. So you say, okay, what's my quotient? 3x squared plus 4x plus 5. What's my remainder? 14. Okay? So it says divide, you're done. If it says write our conclusion using the division statement, this is a division statement. It's basically equivalent expressions. If you have your dividend as one side, you get that the other side that has to equal that is, if I multiply the divisor and the quotient together, I should get a polynomial, and then I have to add the remainder to make it actually equal the original if there's a remainder. So in this case, 3x cubed minus 5x squared minus 7x minus 1, the dividend equals the divisor, x minus 3, times the quotient, 3x squared plus 4x plus 5, plus remainder 14. If I expand the right side here, it will equal the left side. Just like our in terms of our number example, okay, we divided by 123, we got 16, and our remainder was, if I multiply this and add 49, I get 2017.
So,
yeah.
When we in that division statement, like
yes.
The quotient, the thing that we calculated is kind of just in the middle, like.
Well, it's quotient, divisor times quotient plus remainder is the pattern.
Is it gonna when we calculate a quotient, is it useful for polynomials?
Yeah, as we proceed, this lesson is basically a bunch of dividing. So it's just can you do this algebraic strategy? So the result is, this is sometimes the way they want you to write your answer. Okay?
Oh, okay.
Now, if the question just says divide, it doesn't say write your answer using the division statement, then this is what you write, what you have here. But if it says write your answer using the division statement, then I'm expecting you to write it like this. Okay? Now, I'm going to erase this, and I'm going to do it one more time, and you guys can do it with me, okay? Because sometimes just copying it isn't help, because you're I just wrote down a whole bunch of things, okay? So I'm going to redo the question. Okay, so whenever you do one of these questions, okay, so I'm going to put 3x cubed minus 5x squared minus 7x minus 1, x minus 3 is in front. Okay, what do I multiply x by to get 3x cubed? 3x squared. 3x squared times x, 3x cubed, 3x squared times negative 3, negative 9x squared. Cancels, because that's subtracted. Negative 5x squared minus negative 9x squared, which really means adding 9x squared is 4x squared. Okay? Drop the next term, minus 7x. What do I multiply x by to get 4x squared? Plus 4x. 4x times x, 4x squared. 4x times negative 3, negative 12x. Those are gone. Negative 7x minus negative 12x, 5x. Okay, writing down the next digit, or next term, -1. What do I multiply x by to get 5x plus 5? 5 times x, 5x. 5 times -3, -15. Subtract, and I get -1 minus -15 is 14. Good enough? Changed colors on you there, I think.
Yeah, I know, I like the colors before.
Okay, sorry. Still color. Okay. Everyone good? Now there are rules to what you are allowed to divide. Okay? And how we divide. So, let's look at the rules. Rule number 1. The divisor must always have a lower degree than the dividend. Okay? So what you're dividing by has to have a lower degree than what you're dividing into. X squared, then I can divide by x's, but I can't divide by x squared. Okay? If I start with x cubed, I can't divide by x to the 4. It doesn't work. Okay? It has to be lower.
Wait, so it's not that big.
Can't do it. Okay? The terms in each polynomial must always be written in descending order of degree. So if the polynomial you're given is not in the correct order of degree, which we've been trying to harp on you since grade 9, put your polynomials in order of degree from highest to lowest. If it's not in that order that you're given, you need to do a rearranging before you do this. Or else, do you guys get, it's like if you don't rearrange it, it's like me saying that 2017 and 7,210 are the same. Right? You can't just switch the order and like, I'm going to get the same answer if I divide into this than I did in the other one. Right? You can't just change the order. So you have to keep the things in the order of degree. And that's true for both the divisor and the dividend. They have to be in order of degree. And then thirdly, this is very important, and a lot of students forget about this. If there's a term missing in the polynomial, so what I mean by missing is, if you know you have degree 3, then technically the polynomial has a degree 3 term, a degree 2 term, a degree 1 term, and a 0 term, and a degree 0 or a constant term. If any term is missing, you need to put a placeholder. And what I mean by a placeholder, if say the x squared term is missing, you put 0x squared. The x term is missing, you put 0x. You need that placeholder, because just think how if you don't have a placeholder, guys, do you guys get that things aren't going to line up? And then things are going to get confusing.
Because like the one that you multiply by x.
Like if, let's say there hadn't been an x squared here, but I didn't put 0x, say this had been 0x squared, I put the placeholder, then everything lines up. But if I didn't put this and 7x was here, do you see problems? Like 7x and 9x squared are now lined up, they shouldn't be.
Wait, so then would you just do like a 9x squared?
Yeah, so if that's a 0x squared minus -9 squared, now it's a 9x squared. You can still subtract, but you need the placeholder to do the correct subtraction.
So it's like we'll be asked to do like division of like 4x to the 8 plus 7x all divided by something, and you have to put like a
Yep.
0x.
You definitely have to put all the flat placeholders that were missing, or else because when you divide, maybe the quotient has a degree 6 term, a degree 5 term, a degree 4 term, a degree 3 term.
Yeah.
Like that's just the way the world works. So you have to you can't just assume that's going to be a nice, easy quotient that only has 2 things as well, right? It could be.
The way the world works.
You got it. Okay. Life lesson. Okay, so let's try that. So here's another example. This says divide. 5x minus 2x cubed plus 3 plus x to the 4 divided by 1 plus 2x plus x squared. So every sort of thing of the rules I just said is basically being tested to you here. So when I actually divide this, right? What is my dividend? What should I start writing for my dividend? Should I start with 5x? X to the 4. I pick the highest degree term. Highest degree term is this. As soon as I know what my highest degree term is, I know how many terms I should be writing. 5. One more than whatever the degree is. Because if I have degree 4, then there's got to be a cubic term, a squared term, a linear term, a constant, plus the cube, plus the original. So there's my 5. Okay? So a general rule is if you have degree n, there's going to be n plus 1 terms. Is everyone cool with that? Okay. So next thing I write is the cubic term. Do I have one?
Yes.
Okay, so I copy it. Minus 2x cubed. I need a quadratic term. Do I have one? So I put my placeholder. 0x squared. Does everyone agree I haven't changed my polynomial? Because 0x squared is really just 0. I've added 0. Okay? Then linear term plus 5x. And then constant term plus 3. So there's my polynomial, the dividend I'm dividing into. Divisor, 1 plus 2x plus x squared, but I should write it as? Okay. I'm going to tell you right now because it always comes up. There's one question in the homework that basically doesn't have a middle term. You would need a placeholder in your divisor too. So if it was just x squared plus 1, you would write x squared plus 0x plus 1 right now. Because you want things all to line up. As soon as things are missing, things won't line up.
When you multiply it.
You'll get a 0x, but it might be underneath something that's not a 0x, and so you need things to line up so that you can get the correct results as you go through. Yeah.
Does it matter, like you know how the highest degree is 4?
Yes.
And the divisor, the highest degree is 2? Does it matter?
Well, it's lower than the degree 4, so we're good. It's also a clue. Do you guys understand what logically should the degree of my quotient be? If I have degree 4 divided by degree 2, it should be degree 2. Because if I multiply two things of degree 2, I should get degree 4. Okay? So that's a clue that I know I'm starting with squares here. The other thing is your remainder can have basically it can't have degree 2, but it could have degree 1 and 0 as part of its remainder. And as we go through this, you'll kind of see where I'm going. So here we go. Let's start the process. What do I multiply x squared by to get x to the 4? X squared. So I'm going to go to my x squared, which I would, if I didn't put a placeholder, I would have no place to put this. You guys see where I'm going here? If I didn't have the placeholder, where would this x squared be going? On top of this? On top of this? Question mark? Like,
so you have like let's just say the question was like you were multiplying by x4, then you would put it above the x.
Yeah. Line things up, then everything's lined up and it looks nice for me. I can mark it very easily and then you won't forget something because everything's lined up. X squared, so this time how many things do I have to multiply by? 3. X squared times x squared, x to the 4. X squared times 2x plus 2x to the 3. X squared times 1, x squared. Okay? The x to the 4's gone because you purposely chose that it would work out like that. Now I'm subtracting. Don't be careful. Negative 2x cubed minus positive 2x cubed. Negative 4x cubed. I have to do another subtraction. There's more to subtract. 0x squared minus x squared. Negative 1x squared or negative x squared. Again, see the importance of that placeholder. Okay? If you have the 5x there, do you see that it's going to be confusing? What are we subtracting? You have to, in your mind, think of the 0x squared, and let's just write it there. Then it's there. Okay, so I know that this time I need 3 things as I'm proceeding, so I'm going to drop down the next term. Now, a question you might have is, what if the 2x cubes had canceled? There. And you only had one term, then you would bring down the next 2.
Oh, you always have 3 because you're divisor?
Yeah, exactly. And then once you no longer have 3, that means you're done with the dividing. And that should make sense. Yeah.
Is there a time where the x won't cross out or no?
No, because you're purposely choosing this, so it will. Yeah. So let's keep going. So now I have to ask myself, what do I multiply x squared by to get negative 4x cubed? Negative 4x. Okay. So negative 4x times x squared is negative 4x cubed. Negative 4x times positive 2x. X squared. Negative 4x times positive 1. Negative 4x. Okay. So goodbye 4x cubed. Goodbye negative 4x cubes because they're the same. They cancel out. Negative x squared minus negative 8x squared. 7x squared. positive 5x minus negative 4x plus 9x. What do I multiply x squared by to get 7x squared?
There will be a break getting say after school and then 3 also wanting to try out I have
And so the quotient should also be in like.
there will be a better tradition meeting oral after school and a
Mhm.
members are always welcome. Second members have been meeting after school today from 3 to 5. The library club will also meet this Wednesday to get the after school. Boys grades 9 and 10, there's a junior boys basketball Wednesday after school at 10 o'clock and Friday morning at 7 p.m. For junior boys basketball, there's Wednesday morning at 7 p.m., Thursday after school, and Friday after school. All boys are welcome. For this year's school, and then it will be after school on Thursday for the anniversary. All are welcome to attend this day. All students, if you're not signed up to the activity, please participate and register this week every day. Attending graduation, doctor's graduation rate, first year,
Is that us?
Yeah, you want those rings. That's so sad. Because it takes 3 years to order them.
Would you like to earn an Irish credit Irish this summer? Toronto Catholic District will the Irish degree, providing students with the opportunity to experience Irish and feminine opportunities that are well-being students. They'll be anticipating taking classes on academy, grades, and students
They don't have nothing to sort it anymore.
I said yes, all are welcome. Reminder, the girls' varsity hockey tryouts are tomorrow, 3 p.m. at the MasterCard Center. All permission must be edited. That is all. You can please send out any outstanding attendance. That would be great.
Okay. So, are you guys? I just want you to kind of understand the whole process here. So, if I expand this right side, it will be kind of tedious, but it's a check. If I expand this side, I get the right side. I get the left side. That means they're the equivalent expressions. I'm going to tell you there's going to be, again, you're not going to be starting this homework until like after the quiz, but when you do the homework, sometimes there might be a question where it's like, I give you the dividend, the quotient, and the remainder, find the divisor. Or I give you the remainder, I give you all the thing on this side, find the dividend. So that will be the annoying one where you have to expand everything.
But then when you expand it, then when you have to divide it again.
No, because your dividend would be the answer.
Like that's actually what.
Like if I tell you, here's a polynomial, has this as the divisor, this is the quotient, this is the remainder, what was the dividend?
Oh,
You have to find it.
so will there be one like find the remainder and then?
Yeah. So
And that's
then,
when you-
if I tell you this, this, and this, and you don't know this, then it's just basically expand this, and then isolate R, and like that's the
Yeah,
remainder.
so then-
Yeah. Okay, you'll see this as you go do the homework. But I want to get through, guys, it's not 10 minutes. There is an alternate method to long division. Would you guys like a shortcut? Okay. So you can only use this shortcut, however, if it's a linear divisor. So what I mean by, you guys all know what I mean by linear divisor? Linear divisor, x minus a. Okay, if your divisor is of the form x minus a, or x, and a can be positive or negative, so x plus number or x minus number. If you have it of this form, you can use something called synthetic division. When you think of the word synthetic, what do you think? Fake. Okay, so we're going to do fake. It's like fake news, fake division. No, you actually get an answer. It's not like fake news. That's pretty fake. Okay. So anyways, fake division, synthetic division. How does this work? We're going to do example 1. We're going to do it again. So we already know the answer to this. What did we get as our answer to number 1 today? 3x squared plus 4x plus 5, remainder 14, right?
How do you remember that?
I purposely made it 3, 4, 5.
Oh. So did you go back?
Okay, so guys, you start with an L shape. I want you to do the same thing we did with the first example. Just sit back and watch for a second.
I like this.
Okay. So and just so you know, the L basically on your paper, this is going to take up 3 lines on your lined paper. So there's a line here, a line here, a line under the horizontal line. Okay? Okay. So along the first line here, the top of the L shape, inside the L, you're going to write the coefficients of your dividend. Coefficients only. The way we do this, X doesn't even come in. Okay? 3, -5, -7, -1. I have listed the coefficients of the dividend. So that's what goes here. Coefficients of dividend. If a term was missing in my dividend, there would be a 0 placeholder. Just like you do placeholders for long division, you still do placeholder. Okay? Over here, you are going to put whatever causes the divisor to, whatever value of X would cause the divisor to be 0. So what number would cause X minus 3 to be 0? 3. So number that causes divisor to equal 0. Okay. I'll have to wait. Okay. I wrote really too tiny here. Okay, sorry. We're gonna. That's good. So it won't be. So this only works for linear. So it won't be. So square doesn't work. Now you might say, what if it was 2x minus 3? There's a little special case, but we're not going to get to that today. We're going to do the basic case today. Okay. Now, this is the process. So please just watch. Pencils down. Then we'll do it together again. First thing you do is whatever the first number is, you drop it below the line. Drop it like it's hot. Okay, drop it. And then you're going to repeatedly do these 2 things. Two operations. You're going to multiply and add. You're going to multiply the 2 things outside of the L. So 3 times 3 is 9. You put your result there. Then you add, and your answer goes below the line. Add -5 and 9, 4. Okay, do it again. 3 times 4 is 12. Add, you get, hey, 3, 4, 5.
6.
3 times 5, 15. -1 plus 15.
No, I don't think so.
But wait a second. What was our divisor? What was our quotient again? 3x squared plus 4x plus 5. And what's your remainder? 14.
Magic.
Is that a lot faster, guys? Okay, so let's do it together. Okay, trust me, you'll like this way. Okay, let's do it again. Okay, let's unconfuse it. Okay, so set up coefficients along the first line. Outside, you put the number that causes the divisor to be 0. In this case, it's 3. Take first number, drop it below. Drop it. Drop it down here. Then you're going to repeatedly multiply, add until you have no more numbers left. Multiply, add. 3 times 3, 9. Add 4. Multiply, 12. Add 5. 5 times 3, 15. Add 14. I typically just kind of cordon off the last digit. That will always be your remainder. So, yeah. Sorry. Hello.
Hi, Sarah.
She is not here today.
Okay.
You're welcome. So, the idea here is you can't just throw that on the paper and drop the mic and be done. You have to tell me the quotient and the remainder. Okay? Okay? Now, again, the placeholders, if the If the dividend had any term missing, we knew as soon as I see it's cubic, I know I should have 4 terms. Oh good, I have 4 terms, so nothing's missing. But if it's degree 3 and there's only 3 terms, then I might have to put a 0 in for one of the spots. Okay? And then everything will line up, and your answer will be, if you start with degree 3 and you divide by linear, then you know this starts at degree 2. It will always start 1 degree less.
But you never
I'll say that one more time. Whatever degree the dividend is, remember your divisor is always degree 1. You can only use this method for linear divisors, so it's always degree 1. Degree 3, degree 1, this must be degree 2. Degree 4, degree 1 must be degree 3. Degree 9, degree 1 must be degree 8. Not that I would ever make you do that. But, okay. Now, I want to do one more example to finish off, because now we're going to practice doing that. One more time, now that we know it's fast.
There's a missing term.
What rule?
The answer is 1 month.
Oh,
Whatever degree your dividend is, your quotient will be 1 degree less. Okay. So divide 13x minus 2x cubed plus x to the 4 minus 6 by x plus 2. So I draw my L shape, and what's going along the top is going to be my coefficients. So I start with the highest degree, and you start with 13. Boo! Maybe like the Princess Bride. Boo!
Wait, I still won.
Okay. Start with the highest degree term. What's the highest degree up there? 4. So the degree, and so the coefficient is 1. Next comes degree 3. Next comes degree 2. I need a placeholder. Next comes degree 1. Next comes constant. Degree 4, n minus 1, 5 terms. Degree 4 polynomial needs 5 numbers here. Got it?
Wait, isn't it?
Yeah, so 4.
So negative. Oh yeah, because the 4.
Did I say minus? I don't know. It's plus 1. Okay, add 1.
Negative.
Okay, so 4 terms, 4, degree 4, 5 terms. There it is. What's the number up in front going to be?
Negative 2.
Good. And now the process. Drop the first number, and then multiply, add until there's no more numbers left. Multiply, add. Good. Multiply, add. Again, see the purpose of the placeholder, guys. Okay? Multiply.
Wait, now you add.
You're adding. 13 plus negative 16. Multiply, and then add.
Your last one's always your remainder.
Yeah.
But does that mean if the remainder is 0, does that mean it could have been?
You're thinking ahead. That's good. I like it. So do we all agree? We start with degree 3. Yippee. Okay. I'm writing. So x cubed minus 4x squared plus 8x minus 3. Remainder 0. That seems like a special result.
Yes, this is.
What does it mean if the remainder is 0? Okay.
There's some meaning to it.
I bet you there is.
But I don't know it.
Okay, before you give me 5 seconds, and you guys. So if I did the division statement here, do you guys get? Okay, so sorry, I'm just writing the ugly version of it. There's your dividend equals divisor times this thing, right? X cubed minus 4x squared plus 8x.
It's in factor.
Oh my gosh, is that factor, guys?
It is.
So x plus 2 is not only a divisor, it's a factor.
Wow.
You just proved that x plus 2 is a factor of that polynomial.
What?
Okay, this is totally it's very important.
I thought it just
Tomorrow, okay guys, tomorrow is quiz checklist. You have a chance to ask you some questions, but I'm finishing this lesson. Okay, have a great night. Yeah.
So I messed up and didn't put -2, but Vaughn's